Welcome back, everybody, for another deep dive. This time, we're going on a bit of a historical tour through C# concurrency. We're going to see how the way developers have made programs do multiple things at once has changed over time and how the tools have evolved. And believe it or not, this trip back in time is actually going to help you write better code today. Our guide for this journey is a great Medium article by Sachin Saikdeva that goes through all the key milestones and how C# handles concurrency.
It's a pretty fascinating evolution. By understanding how things developed, you get a much deeper understanding of why C-sharp concurrency works the way it does today and what problems each step was trying to solve.
So no dry history lessons here. This is all about practical insights. Let's set the scene. It's the early 2000s, .NET 1.0, the Wild West era of C# concurrency. What was it like for developers back then?
Well, imagine you're a developer in 2002, and you've got this brand new language, C-sharp, and you want to make your program do a bunch of things at once. What's the tool you've got? The thread class. Sounds straightforward enough, right? Create a new thread object for each task, and off it goes. But this direct control came with a lot of baggage.
The article makes it sound like a bit of a mess. Was it really that wild?
Oh, it could be, yeah. Like, scaling was a huge problem. If your application needed to handle tons of operations happening at the same time, managing all those different threads was just a logistical nightmare. Trying to keep track of a room full of toddlers, that kind of chaos.
So a lot of potential for things to crash and burn, I'd imagine.
Absolutely. One thread goes rogue, and the whole thing could come crashing down. And debugging. Ugh. Forget trying to find a needle in a haystack. This was like trying to find a specific grain of sand on the beach. And then you've got resource management to worry about too. One thread hogs all the CPU or memory, starves out all the others, and bam, performance bottlenecks, unhappy users, the whole 9 yards.
Okay, so it sounds like the Wild West was a pretty rough place for C# developers. Thankfully, things didn't stay that way for long.
Right, you are. Along came .NET 1.1 in 2003, and with it, the thread pool. This was a big improvement over the thread class free-for-all.
Thread pool, that does sound a little more organized. What was the big idea there?
Instead of constantly creating and destroying threads, which really eats up resources, the runtime would maintain a pool of worker threads ready to go. It's like a taxi stand. You don't build a new car for every passenger, you just send out the next available one. This made threads reusable and really boosted performance.
So a much smoother experience for both developers and the application itself.
Yeah, exactly. But the thread pool still wasn't perfect. One of the downsides was that you didn't have that much control. Once a task was submitted to the pool, you couldn't really micromanage how or when it got done.
Oh, so still at the mercy of the pool manager, as it were. But hey, at least it was a step toward a more manageable approach. Let's move on to .NET 2.0 in 2005. We see delegates and begin invoke enter the scene. Was this a big jump forward?
It was kind of an awkward, but definitely an important step into the world of asynchronous programming. They let you execute methods without having to mess around with threads directly, which was nice, but you still had to deal with callbacks, and those could get really messy when you had lots of things happening at once.
So not quite the slick solution we have today, I'm guessing. The article compared it to sending a message in a bottle, which doesn't exactly scream cutting-edge technology.
Yeah, that's a good way to put it. You just kind of tossed the operation out there and hoped for the best, but you didn't have a whole lot of control over when or how it got done.
All right, so we've got cowboys, taxis, and messages in bottles. What's next in this C# concurrency adventure?
Well, next up is the Task Parallel Library, TPL for short. That arrived with .NET 4.0 in 2010. This was a real turning point, a move toward a much more organized and manageable way of doing concurrency.
Ah, the TPL. This is where things start to look a little more familiar, right?
Yeah.
Was the task concept a huge change from what came before?
Task was a total game changer. It really abstracted away a lot of that low-level thread management. Developers could finally focus on the logic of their concurrent operations instead of getting lost in the nitty-gritty of how to make it all work.
The article talks about the TPL's structured approach.
Hmm.
What did that look like in practice?
It gave developers a framework for organizing and putting tasks together. Like building with Legos, you could link tasks, say which ones depended on others, and handle any errors in a much more organized way. Code was suddenly a lot easier to read, write, and maintain, which was a huge relief.
That sounds like a huge win for developers. So the TPL really set the stage for the smooth concurrency solutions we've got today.
Absolutely, and it didn't stop there. The TPL also introduced the idea of automatic thread management. The runtime itself took care of assigning tasks to threads, optimizing how resources were used, and making sure things ran efficiently. No more micromanaging every single thread. Developers could finally zoom out and focus on the bigger picture.
And if I remember correctly, this is also where we start to see the real power of multi-core processors unleashed.
You got it. The TPL was designed with parallel processing in mind from the get-go, making it easy to take advantage of those multi-core systems to really crank up performance. Applications could now handle way more operations at the same time, process data faster, and respond to users more quickly. It was a big deal.
Okay, so the TPL was a huge step forward. It brought structure, efficiency, and scalability to C# concurrency. But there's still one more chapter in this story, and it's a big one. The arrival of async and await in .NET 4.5. The article calls this a revolution, not just an improvement. Were people really that resistant to the TPL way of doing things?
Well, the TPL definitely provided a solid foundation, but it could still be a bit clunky when it came to actually writing asynchronous code. You'd end up wrestling with continuation tasks and callbacks, and let me tell you, that made for some code that was a pain to read and even harder to debug. Async await changed the game entirely.
So it wasn't just about making things a little easier. This was a fundamental shift in how developers thought about asynchronous programming.
Exactly. Async await was like magic. It let you write asynchronous code that looked and felt almost exactly like regular synchronous code. You could use all the usual stuff like if statements and loops without jumping through all those hoops to handle the asynchronous parts. It was a huge simplification.
So no more spaghetti code with callbacks and continuations all over the place.
You got it. Code became so much cleaner, easier to read, and way easier to maintain. And it wasn't just about making things look pretty either. This new way of doing things made it way easier to understand how the code actually flowed, especially when dealing with all this asynchronous stuff. That's crucial for avoiding those sneaky bugs that can pop up when things are happening at the same time.
Now I see why this was such a game changer. It's like the difference between trying to navigate a city with a confusing map and having a GPS guide you effortlessly to your destination.
Yeah, that's a great way to put it. Async await really did simplify the whole process of writing and understanding asynchronous code. It was a huge leap forward.
All right, so we've come a long way. From the wild west of manual thread management to the structure and efficiency of the TPL, and finally to the elegance and simplicity of async await. Quite a journey. But I have a feeling the evolution of C# concurrency didn't just stop there, did it?
You're right, it didn't. Even with async await, the quest for better concurrency tools continued, leading to some really interesting refinements in .NET Core and .NET 5 Plus off. Want to dive into those?
You're exactly right. It didn't stop there. C#'s concurrency story, it doesn't end with async await. .NET Core and .NET 5 Plus off, they brought some really cool refinements, really focus on things like performance, specialized use cases, and just making developers' lives even easier.
Let's get into those. One that jumped out at me in the article was parallel.forEach. Is this about taking the power of multi-core processors to the next level?
Yeah, that's exactly it. Parallel for each. It's all about processing large collections of data efficiently. So imagine you've got, say, a list of thousands of images and you need to resize them all. Well, with parallel for each, you can split that work up across multiple cores, each core handling a chunk of the images at the same time.
So instead of resizing one image at a time, you're doing a bunch of them simultaneously, which obviously means a much faster overall execution time. Exactly. It's a really elegant way to tap into the power of modern hardware for tasks that are well suited to being done in parallel. And the best part is, it's often as simple as just swapping out a regular for each loop with parallel for each. The framework takes care of all the messy stuff, dividing the work, managing the threads. You don't have to worry about it.
That sounds almost too easy.
Mm-hmm.
Are there any gotchas or things developers should be careful about when they're using parallel for each?
Well, of course, like any powerful tool, you got to use it wisely. Not every task is a good candidate for parallelization. If the operations you're doing depend on each other, or if they need to access some shared resource one at a time, then going parallel could actually create more problems than it solves.
So you really need to understand the nature of the task at hand. You wouldn't want to parallelize a recipe that requires adding ingredients in a specific order, right?
That's a perfect analogy. And there's also the overhead of managing multiple threads. You've got to consider that. If the work you're doing in each iteration is really small, the cost of managing those threads might actually outweigh the performance gains you get from going parallel.
That makes sense. It's about finding that sweet spot, the right balance between concurrency and efficiency. Speaking of efficiency, the article also mentioned value task. What's so valuable about it?
So value task is all about getting even more performance out of asynchronous operations. Sometimes an asynchronous operation might actually finish synchronously, and with the traditional task object, you still had to pay the price of creating and managing that object even if the operation finished right away.
So it's like ordering something for a next day delivery, and then the delivery person shows up at your door 5 minutes later.
Exactly. Value task came along to solve this. It can handle both synchronous and asynchronous operations, and it only creates the full task object when it's really needed. This can really cut down on memory usage and garbage collection, especially in high-performance situations where you've got tons of little asynchronous operations flying around.
Ah, so it's like having a lighter, more agile option for those quick asynchronous tasks, saving the heavier machinery for the bigger jobs. From optimizing performance, we move on to something that sounds a little more specialized. Async enumerable. What's the story behind this one?
iSync enumerable is a really powerful tool when you're dealing with streams of data, where the data is coming in asynchronously, bit by bit. Think of it like getting a stream of stock quotes or sensor data from a device where the data arrives in chunks over time, not all at once.
Okay, I'm trying to picture this. So would reading a massive file chunk by chunk also be a good use case for async enumerable?
Absolutely. Instead of waiting for the whole file to load into memory, which can take forever and hog a ton of resources, you can start processing those chunks as they come in. This makes your application much snappier and more efficient.
So it's like building a bridge brick by brick as the materials arrive, rather than waiting for the whole delivery before you even start.
Perfect analogy. Async enumerable. It's a core part of modern asynchronous programming in C#, especially when you're dealing with situations where you need to process data as it streams in.
It's pretty amazing to see how C# has constantly evolved to keep up with the ever-increasing demands of modern software development. From the wild west of manual thread management to the structure and efficiency of the TPL, and then the elegance of async await, and now these performance refinements with features like parallel for each and value task. What a journey.
It really has been. And it's a testament to the language designers and the whole C# community. They just keep pushing the boundaries of what's possible.
Speaking of pushing boundaries, I can't help but wonder what's next for C# concurrency. What challenges do you think it needs to tackle to keep up with all the crazy technological advancements happening around us?
That's a great question. One area that's becoming more and more important is the whole world of distributed systems. As more applications move to the cloud and spread across multiple servers, managing concurrency gets a lot more complicated. We need better tools and techniques to help us deal with asynchronous operations that are happening across a network, handle latency and failures gracefully, and make sure the data stays consistent in this kind of distributed environment.
So it's like going from managing a well-organized kitchen to coordinating a banquet across multiple kitchens, each with its own set of challenges and potential disasters waiting to happen.
Exactly. And this is where things get really interesting. Those traditional concurrency concepts like threads and locks, they might not be enough anymore. We might need to start thinking about higher level abstractions that let us express these distributed workflows and manage concurrency at a more abstract level.
It sounds like we're entering a whole new frontier, but also a realm full of exciting possibilities. What other technological trends do you see potentially shaping the future of C# concurrency?
One area that really fascinates me is the connection between concurrency and artificial intelligence. AI systems are inherently parallel, processing tons of data and doing complex calculations all at the same time. And this is where all those advancements we've seen in C# concurrency can really shine, giving us the tools and frameworks to build AI applications that are both efficient and scalable.
So C# concurrency could actually become a crucial ingredient in the AI revolution.
Absolutely. And the influence could go both ways. Imagine having AI-powered tools that help developers write better concurrent code, automatically spot potential race conditions, or even suggest optimizations for parallel processing. That would be incredible.
Having an AI assistant to help navigate the complexities of concurrency, that would be a game changer for sure.
It would. And as AI keeps getting smarter, we might see even more radical changes. Imagine programming languages and frameworks specifically designed for quantum computing, where concurrency isn't just a feature, it's baked into the very foundation of how the computation works.
Quantum computing. That's a whole other level of mind-blowing concurrency. It makes you wonder what other technological leaps are going to influence this field in the future.
The possibilities are truly endless. And that's what makes C-sharp concurrency so exciting. It's this ever-changing landscape, constantly evolving because of the need to solve real-world problems and to harness the power of all these amazing technological advancements.
And as C-sharp concurrency evolves, so too must the developers who use it.
Yeah.
How do you see these advancements changing the way developers think about and approach problem solving?
Yeah, it's a fascinating thing to think about. As the C-sharp concurrency has gotten more advanced, it's also become, I'd say, more approachable. This move toward higher level abstractions like async-await, it's really changed how developers think about concurrency. We're not really messing around with threads directly anymore or worrying about those low-level details. Instead, it's more about thinking in terms of tasks, asynchronous operations, composing workflows, that kind of thing. It's a much more declarative and expressive way to write concurrent code.
So it's kind of like the difference between, say, writing assembly language and using a high-level language like C-sharp itself. You're working at a higher level, focusing on what you want to do rather than the nuts and bolts of how the machine actually executes those instructions.
That's a great analogy. And that shift in thinking has a big impact on how readable the code is, how easy it is to maintain, and in the end, how productive developers can be. It lets developers really focus on the logic of what their application is doing rather than getting lost in the weeds of thread management. But, there's always a trade-off.
Ah, yes, the inevitable trade-off. Do you worry that with all this abstraction, developers might lose sight of what's actually happening under the hood? Concurrency is still a tricky beast, even with all these fantastic tools we have now.
That's a fair point. I think it's important for developers to have at least a basic understanding of how concurrency works at a lower level, even if they're not directly managing threads anymore. Knowing about potential problems like race conditions and deadlocks can help them write code that's more reliable and less likely to break.
So it's a balance, really. We want to make concurrency more accessible, less intimidating, but without hiding all the inherent challenges completely. Back in the Wild West days, you had to be super aware of those challenges, but now the tools take care of a lot of that heavy lifting.
Exactly. The focus now is on understanding those abstractions and using them the right way. A modern C-sharp developer, they need to be comfortable thinking about asynchronous workflows, knowing how to put tasks together effectively, and understanding when to use those more specialized tools like parallel.forh or iasync enumerable.
It sounds like the role of the developer is evolving too, going from a low-level mechanic to a high-level architect, someone who designs systems that can handle all the complexities of concurrency without breaking a sweat.
I like that. And as systems become more distributed, more reliant on AI, and who knows, maybe even venture into the realm of quantum computing, the need for developers who can think this way, in this architectural way, it's only going to grow.
Well, we've covered a lot of ground today, from those early days of manually managing threads to the potential of AI-assisted concurrency and even quantum computing. What would you say is the big takeaway for our listeners as they navigate this constantly changing world?
The key takeaway, I think it's this. C-sharp concurrency, it's a constantly evolving landscape, but it's also full of exciting possibilities. By understanding the history, embracing the new tools and techniques, and keeping an eye on emerging trends, developers can really unlock the power of concurrency and build some amazing applications.
What a journey it's been, and what an exciting future we have ahead of us. So, to our listeners out there, keep exploring, keep experimenting, and keep pushing the limits of what you can do with C-sharp concurrency. The future is yours to code.
And don't forget, the world of C-sharp concurrency, it's full of fascinating challenges and incredibly rewarding discoveries. Embrace the journey and never stop learning.
That's all the time we have for today, folks. Thanks for joining us on another deep dive. We'll catch you next time.